of the worksheet. The line L has equation this, the point P has position vector this. Show that the perpendicular distance from P to L is square root of 5. Okay, so we're given a vector line with equation R equals 4, 2, minus 1 plus T 2 minus 1 minus 2. And then there's a point whose position vector is 2j plus 4. Okay, so this is P, and we know that OP is 0, 2, and 4. Okay. Show that the perpendicular distance from P to L is under root 5. Okay, so we have to show that this distance is square root of 5. All right. So what we'll do, we're calling this point X. And first of all, we're going to say that OX, since X is lying on the vector line, so OX will have position vector 4 plus 2t, 2 minus t, and minus 1 minus 2t. 4, 2 minus 1, and 2 minus 1 minus 2t. Okay. Now we know that Px dot Ox has to be 0 since there's a right angle in between them. Now let's find Px first. Px would be, in fact, it's not going to be Px dot Ox. It's going to be Px dot this position vector, this direction vector. Because this vector is parallel to the purple vector, so there's going to be a right angle between this and this as well. So instead of the whole vector in terms of t, you're only going to extract its direction vector. So I'm going to write the direction vector over there. So no need to take entire Ox because Ox is also in terms of t. So we don't need double t's in the same equation. So this would be 2 minus 1 minus 2. Okay, so Px would be Ox minus OP, which is going to be 4 plus 2t, 2 minus t, and minus 1 minus 2t, minus OP, which is 0 to 4. So Px is going to be 4 plus 2t, 2 minus t. Please do the working along with me so that if there's a mistake, can be found. So this would be minus 5 minus 2. Okay. And this is going to be 0. 0 minus 4. 0 minus 2. 2 minus 2 is 0. Okay. So now let's take the dot product. 4 plus 2t minus t minus 5 minus 2t dot the direction vector of Ox, or the direction vector of the line R, which is 2 minus 1 minus 2. And that would be equals to 0. So from here, we're going to find the value of T8 plus 4t plus t plus 10 plus 4t equals to 0. Let me see. 8 plus 4t plus t plus 10 plus 44. So this is 9t equals minus 18. So t is equals to minus 2. Let me check. P is minus 2. So if we have T, now we can find the vector Px represented highlighted by the yellow part in the diagram. Let's find vector Px and then we're going to find its magnitude. So Px is going to be, where's the expression for Px? It's right here. So now substitute T equals minus 2. So there's a 0 here, then there's a plus 2 here. So if T is minus 2, that would be minus 1. So now I'm going to take the magnitude of this, which is going to be 0 square plus 2 square plus 1 square, which gives square root of 5. That is correct. Moving on. The lines L and M have vector equations this and this, respectively. Show LM and M intersect and find the point of intersection. Okay. So you haven't been asked to show if the lines are parallel. Agar ye kaha hota, so first you would have checked that if these two vectors, the direction vectors, are they scalar multiple of each other? And if they were scalar multiple of each other, so you would have said that yes, they are parallel. Anyway, that is not really related to this question. Okay, so we have to show that the two vectors intersect and then we have to find the point of intersection. So the first vector can be written as 1 minus 2, 0 plus s times 2, 1, 3. And the other one is r equals 6 minus 5, 4 plus t 1 minus 2, 1. Okay, now we need to find the point of intersection of these two three-dimensional lines. So we're going to solve them simultaneously. So we have 1 plus 2s and minus 2 plus s and 0 plus 3s on the left hand side, and on the right side of each equality we have 6 plus t minus 5 minus 2t.
J0 और k minus 2 ये first vector में.
First vector में I, J and K. ठीक है बिल्कुल. Thank you for pointing that out. J is 0 here and K is minus 2. ठीक है. That's 0 and then minus 2. Okay. So we need to fix this and this. So we have S equals minus 5 minus 2t. Okay, ठीक है. Minus 2 plus 3s equals plus t. Let me just double check. 1 plus 2x equals 6 plus t. S is equals to minus 5 minus 2t minus 2 plus 3s is equals to 4 plus t. Okay, so you may solve any two of these lines first. Any two of these equations, I'm going to solve the first and the second equation simultaneously. So we know that S is equals to this. I'm going to substitute it in the first equation. So I have 1 plus 2 times minus 5 minus 2t equals 6 plus t. So 1 minus 10 minus 4t equals 6 plus t. 5t equals minus 15 and t equals minus 3. And if t is equals to -3, then s would be -5 minus 2 times -3. So that's going to be 1. So let me check. यहाँ तक ठीक है या कोई एग्जाम्पल 1 and -3. Yes. Okay. So now what I'll do, I'll substitute the value of t and the value of s here and here. And if we get the exactly the 3 same coordinates on both sides, that means that is the point of intersection. And if even one of the coordinates is incorrect or are not, one of the coordinates is not equal, which is going to be the third one, by the way, third one decisive होता है, क्योंकि you used s and t from these two equations and you got an s and t, then you have to check that whether that s and t satisfies the third equation or not. So it's always the third point that tells you whether the lines are intersecting or not. So third wala is different hota hai agar intersecting. Now first two to hamesha same hona chahiye. Okay, aur agar nahi hai, that means you've made a mistake. Okay, so for the first one we have 1 plus 2s is going to be s kya aaya tha 1 hi aaya tha? Yes. Okay, so we have 3. Then 0 plus s is going to be 1 again. And then -2 plus 3s is going to be 1 again. So 3, 1, 1 are left hand side. Let's check the right hand side. T is -3. So we get 3. 6 minus 3 is 3. And then we get -5 plus 6, which is 1. And then we get 4 minus 3, which is 1. So where the point of intersection is 3, 1, 1. Okay, it says find the position vector of the point of intersection. So you must write the position vector then. So you write 3i plus 3j. Oh, sorry, 3i plus j plus k is the position vector of the point of intersection. Had they asked, write the coordinates of the point of intersection, you would have written 3, 3, 1, 1. You cannot leave the answer like this if the question is in IJK format. Your answer should also be in IJK format. Otherwise, yeah, you get penalized. Oh, so this was question 5. Question 6 करते हैं. The lines L and M have vector equations, this and this, respectively, show that L and M do not intersect. So exactly the same process जो हमने ऊपर किया है, but in the end we'll see that the third point of intersection is third point of both the coordinates is not the same. Okay, so we're going to show that they do not intersect. So the first thing, in fact, you should check is whether they are parallel, which they're not, but you should show that part. K times, this is 1, 1 and -1. So k times 1, 1 and -1 is not equals to this -2, 1 and 1. So since their direction vectors are not scalar multiples of each other, that means the actual vectors are not parallel. So hence not parallel. So that is cleared. Okay. Now we're going to solve them simultaneously. So we have 2 minus 1, 4 plus s minus s equals to -2, 2, 1 minus 2t plus t plus t. Okay. Equate these. 2 plus s equals minus 2t. Minus 1 plus s equals 2 plus t. And 4 minus s is equals to 1 plus t. Okay. From here, I'm going to say that t equals, बल्कि s कर देते हैं. Let's make s the subject. S equals t plus 3. I'm going to substitute it in the upper equation. 2 plus t plus 3 equals minus 2t. Find the value of t from here. So we have 3t equals minus 3t equals minus 8. That's a weird answer. 6, 7, 7. So t equals minus 7 over 3. I have a strong feeling something has gone wrong somewhere. Question 6. Part 1. Yes, yeah, t is supposed to be minus 7 by 3. Anyway, so s would be then t plus 3. So minus 7 by 3 plus 3 is 2 by 3. Now substitute it in both sides, here and here. So we got t equals minus 7 by 3 and s equals 2 by 3. So first one is 8 by 3, 2 plus s. Then we have minus 1 plus 2 by 3, which is minus 1 by 3. Then we have 4 minus 2 by 3, which is 10 by 3. Okay, now we're going to substitute the value of t at the right hand side. Minus 2 times minus 7 by 3, which gives 8 by 3. Then 2 minus 7 by 3 gives minus 1 by 3. And 1 minus 7 by 3 gives minus 4 by 3. Since all 3 points are not satisfied, hence lines are not intersecting. Since all 3 points are not, or all 3 equations or all 3 points are not satisfied, we कह सकते हो, या are not equal, hence vectors, yeah, lines do not intersect. और नहीं, that was the first part. अभी तो काफी question रहता है. Okay. Part 2. Given the lines PQ is perpendicular to L, find the position vector of P. Okay. Here's the vector line, which is L. Which one was this? L, this one. Okay. Point P lies on L and point Q has position vector 2i minus k. Okay. So line, this is line L. Point P lies on it somewhere. And Q has position vector 2i minus k. So Q will be somewhere over here. Because they're saying the line PQ is perpendicular to L. Find the position vector of P. Okay, so we already know the position vector of Q. OQ is two, 0, minus 1. Okay. And position vector of OP will be extracted from here since point P lies on the line. So position vector of OP is going to be 2 plus S minus 1 plus S and 4 minus S. Let me confirm. 2 plus S minus 1 plus S and 4 minus S. Okay. Then the dot product of QP, this, and the direction vector of the line L, this, is going to be 0. So dot product of QP and 1, 1 minus 1 is going to be 0. Like I said before, the direction vector is a vector parallel to the pink vector. So this will also have a 90-degree between them. Okay, so finding QP first, which is going to be OP minus OQ. OP is, acha, we don't know Q. We don't know P. That PQ is perpendicular to L.
मैम P लाइन के ऊपर है.
हाँ, sorry. 2 plus S minus 1 plus S, OP तो हमें पहले ही पता है, 4 minus S minus OQ, which is 2, 0, minus 1. This will give us QP. So that's going to be S minus 3 plus S and 5 minus S. Let me double check. अक्सर गलत हुआ होता है. S minus 3 plus S or 5.
मैम S minus 1 आएगा दूसरा वाला. मैम J के coordinates S minus 1 है.
हाँ, 4 minus 1 है तो 3 होना चाहिए. Yes, this would be 3. 3 minus S. 3 minus S. और एक और middle वाला भी गलत लिखा. Wait, it's going to be S and then that is 0. OQ, yes. तो वो 0 है तो फिर -1 plus S ही होना चाहिए था. पता नहीं वो कौन सा है. Looking at ये middle वाला भी गलत था. So -1 plus S. It's not going to change. 0 से subtract होगा. And the last one is, last one में तो plus नहीं हो जाएगा तो 5 ठीक था. 4
Yes मैम.
minus
5
minus
minus
5 ठीक. Okay. I hope this is correct. Okay. So we have QP. Now we're ready to take the dot product. S minus 1 plus S and 5 minus S dot 1, 1 minus 1 equals 0. That would be S minus 1 plus S minus 5 plus S equals 0. एस और फाइव बिल्कुल एक जैसा लग रहा है. S minus 1 plus S and then minus 5 plus S equals to 0. So we have 3S equals minus 9. 9 minus 9, 9 is 6. This is S, this is S, and this is S. So that makes 3S, and that's minus 6. That goes to the other side, becomes 6. So we're getting S equals to 2. अब पहले मुझे चेक करने दो किसका आंसर S equals to 2 है. Yes, S is 2. Okay. So when S is 2, what do we need to find? Position vector of P. So we already have the expression for that. All that's left to do is substitute the value of S. So OP would be, there should have been a vector sign here, a vector sign here. So OP would be 4, and then 1, and then 2. So the position vector OP, the final mark would be for 4i plus j plus 2k. Which is correct. They have clearly asked for the position vector. So you must write IJK format because that's the format of the question. You cannot write 4, 1, 2. That would have been your answer if the question asked for the coordinates of the. Verify Q lies on M and PQ is perpendicular to M. इससे ज्यादा क्वेश्चन को ये ड्रैग नहीं कर सकते थे. खैर अब 3 करते हैं. Let me just clear space. The lesson might end soon, so Heather, if you could please start a meeting and send us all a link after that. Verify that Q lies on M. So where's M? Right here. This is the line M. You have to show that the point Q lies on this line. अच्छा अब ये कैसे करेंगे? What's the equation of line M? -2, 2, 1 plus T -2, 1, 1. Okay. Now, how do you show that the point Q lies on this line? You replace R with 2, 0, -1. The coordinates of Q. 2, 0, -1. So IJK, yes. And equate it to the right hand side, which is -2, -2t, 2 plus t, and 1 plus t. -2, -2t, 2 plus t, and 1 plus t. Now, all that's left to do is solve all 3 equations, and you should get the same value of t. If you get the same value of t for all 3 equations, that means yes, Q does lie on the same line. Okay. So when 2 is -2 so we have 4 divided by -2. So t comes out to be -2 for the first equation. Then we have 0 is equals to 2 plus t, which is again t equals -2. And in the end, we have -1 is equals to 1 plus t, which is t is equals to -2. So since t is constant, hence Q lies on the line M. Yeah, t is the same, or t is -2 for all 3 equations. Since t is constant, Q lies on line M. What happens is that I'm just discussing some side theory since many of you were absent in the very first lesson of this chapter. Okay, होता क्या है कि अब Q के लिए T has a fixed value which is -2. So when T is -2, you get Q. अब यहाँ पे एक और point है, let's say T, capital T. For this particular point, there will be another one fixed value of T, for example, 7. Then if there's another point on this line, let's say X. For this X, the T will have one fixed value, for example, 9. And when you substitute 9 here, you'll get 3 coordinates of X. So that is how the equation of vectors work. हर coordinate के लिए on that vector line, there's a separate value. But it has to be one fixed value of T that you use to find all 3 coordinates of that particular point. Okay. Part 3, verify that Q. Okay. And that PQ is perpendicular to M. ये भी हमने देखा है. So Q के अब हमारे पास coordinates हैं. Q के coordinates, yes, let's find the coordinates of Q. So OQ is, let me clear this. OQ is, we're doing part 3. Second part of it. So the points of the position vector of OQ is, so I've done the solution of second part of part 3, which is show that PQ is perpendicular to M. Now from the previous part, we already have the point P or the position vector of P, and also from the question we have Q, the position vector of Q, and they're saying that you have to show that the line PQ is perpendicular to this vector line M. So find the vector PQ first, which will be OQ minus OP, which is this. And now the dot product of these two would be 0. So you'll find the dot product of PQ and just the direction vector of R. So when you do that, you get 0, and hence that is the proof that PQ is perpendicular to M. Next question. Find with respect to region O, points A and B. No, sorry, with respect to region O, the points A and B are this and this. The point P lies on the line AB and OP is perpendicular to AB. Okay. So there's a line AB. Let's say A is somewhere over here, for example, B is somewhere over here. P lies on the line AB. And OP is perpendicular to AB. Let's find the line AB first. So the line AB would be R is equals to A plus T, B minus A, since we have 2 coordinates on this line. So R will be 1, 2, 2 plus T, B minus A, which is 3, 4, 0, 0 minus A, which is 1, 2. So then the equation of this line would be R equals 1, 2, 2 plus T times 2, 2 and minus 2. That is the equation of line passing through points A and B. Point P lies on AB. P is somewhere over there. And OP is perpendicular to AB. Find vector equation of AB. So we're done with part 1. And find the coordinates of, find the position vector of P. अब ये कैसे करें? If OP is perpendicular to AB. Okay. OP lies on the same vector. So OP will have coordinates. Question is not making much sense to me, but chalo karte hain. OP will have the same coordinates as the vector equation itself. So it's going to be 1. Point P lies on line AB. Okay. So 1 plus 2t, 2 plus 2t, and 2 minus 2. Okay. And then find the vector AB. AB would be OB minus OA, which we've already done, by the way. This we did OB minus OA, which gave us this 2, 2 minus 2. Okay, so now we have to find the dot product of OP and this position vector 2, 2 minus 2, and it should be equals to 0. And from here, find the value of t and substitute it in OP. That will give you the position vector of t. So OP is 1 plus 2t, 2 plus 2t, and 2 minus 2. Dot 2, 2 minus 2, and equate it to 0. So we get 2 plus 4t plus 4 plus 4t minus 4 plus 4t equals to 0. So we have 12t equals minus 2 and t equals minus 1 by 6. Let me check if it's correct or not. So it is correct. Okay. When t has this value, let's find OP. That would be 1 minus 2 by 6, which is 2/3. 2 plus 2 times minus 1 by 6, which is 5/3. And 2 minus 2 times minus 1 by 6, which is 7/3. So OP is 2 by 3i plus 5 by 3j plus 7 by 3k. Yes, that is the correct answer. All right, that's all for today. And as homework, you're going to do question 8. Allah Hafiz, see you tomorrow.
Allah Hafiz, ma'am.